Ancillary services can be modeled in PLEXOS using the reserves class. This class can be enabled from the config menu by checking this box, and the relevant properties required can be selected from the different options here. For the exercise, we want to make sure that the min provision and the value of reserve shortfall properties for the reserves class are selected, and the reserve.generator's max response property is also selected. I could have navigated to this same property from the generator class by locating generator.reserves and selecting the corresponding property. With the properties selected, I can create the reserve object to be modeled. In this case, the object is called spinning reserve. I can also create a scenario object called reserves so that any properties I define for the reserve object can be tagged with this scenario. The properties for the spinning reserve object can be input based on the values provided. The reserve object we are modeling is of a raise type, and the different types of reserves that could be modeled can be viewed by highlighting the type property and pressing F1 on the keyboard to see a list of all the types of reserves that can be modeled in PLEXOS. The value of reserve shortfall is defined as $1,000, which means that this requirement of 50 megawatts, which is the minimum provision, can be violated at a cost of $1,000 for every megawatt of violation. After the reserve object has been created and the properties defined, memberships have to be created between those system elements which can contribute towards the reserve requirement. This can be done by dragging and dropping the resources into the corresponding reserve object, and the maximum response of each of these generate objects towards the reserve requirement can be defined on the max response property. These properties are also tagged with the reserve scenario that was created. Once this is complete, we can then go to the Simulation tab, create a copy of the reserve, the base plus run-of-river model, and call it run-of-river with reserves. The reserves scenario has to be included in this model for the reserve properties to take effect. Taking a quick look at some of the different settings of this model, I can double-click the object and check the simulation horizon. For reports, I need to make sure that the relevant properties are selected, and these properties for the reserve class have to be selected before running the simulation. I'm also interested in taking a look at the individual contribution of generators towards the reserve requirement. The ST is being run on a nodal basis, and we're using Express MP in this case for the performance object. With all of those settings in place, we can right-click the model and execute. And once the simulation is complete, we can open the solution. Since we're interested in reserves, I can highlight the reserve class and take a look at these different properties that show up on the left-hand side. I'm running the query on an interval basis for the 1 day for which the simulation was run. With these aspects selected, I can run the query and pivot by properties so that it is a little easier to view them. The reserve requirement is being met in every interval, hence there is no shortage reported. The available response is the amount or the megawatts available from the different generators that could contribute towards the reserve requirement. I can pin this tab and query some of the reserve.generator properties. Let's take a look at the available response and provision properties. For the coal generator, in the first 8 hours, since it is providing 480 megawatts towards the energy requirement, out of its 500 megawatts of capacity, 20 megawatts are available to be provided towards reserves. Similarly, for the other generators, their available response can be checked. And the provision can be checked for the corresponding generators. Here, Gas Gen 2 provides 10 megawatts towards the reserve requirement in the first 8 hours. And we have the hydro generator providing the remaining 40 towards the reserve requirement for the first 8 hours. It would be easier to see this if I query only the provision property and pivot by names, and I can see on an hourly basis which generators are contributing to the reserve requirement. Again, for the available response as well, I can highlight the property and run the query, and we can see how much capacity each generator has to contribute towards the reserve requirement. The sum of the total available response in the first hour is 160 megawatts, which is what we saw in our previous query as well, when we were looking at the spinning reserve available response.